Today we discuss how energy is conserved during chemical reactions. We need to do this because we need to be able to explain why reactions gain or lose energy. And our success criteria for today is being able to describe the breaking and forming of bonds as endothermic or exothermic, and describe if a chemical reaction is overall endothermic or exothermic. So just like all other matter, chemical reactions must obey the law of conservation of energy. This is a description of physics and reality that says that energy cannot be created or destroyed. It can only convert from one form to another. So we can take light energy and turn it into electrical energy. We can take chemical potential energy and turn it into heat, but we can't just create heat out of nothing. It's not possible. Reality will not allow it. Now, it might look like when you burn something in a combustion reaction, you're creating heat out of nothing. But really what's happening is the energy becoming the heat is already there. It's just trapped in the bonds of the reactant that you are burning. So, for example, in combustion reactions, we have oxygen as one of our reactants and water vapor as one of our products. The bonds within a water or within an oxygen molecule must break in order for the reaction to take place. And breaking those oxygen atoms apart from each other requires them to absorb energy. They're taking energy in. But new bonds also get to form between oxygens and hydrogens, which will create our H2O, our water molecules. And when those new bonds form, energy is going to be released. So, because the released energy in combustion reactions is so much greater than the absorbed energy, overall, combustion reactions release a lot of energy, which is why they're useful to us. They create heat that can warm us up, or it can be used to fuel another energy transformation, like in a steam engine. So the energy released or absorbed during a reaction is always equal to the difference between the energy required to break the bonds and the energy liberated when the bonds form. So breaking the bonds of reactants is always an absorption of energy, and forming the bonds of the products is always a release of energy. And the difference between those two numbers determines if energy gets absorbed or energy gets released by the reaction. Forming new chemical bonds, releasing energy, is called an exothermic process. Exo means out, so exothermic means outwards heat, because energy is moving out into the environment. Whereas breaking the chemical bonds in the reactants is an endothermic reaction, or endothermic reaction. Endo meaning in, so inward energy. Energy is being taken into the chemical. So we can apply this to the breaking and forming of bonds, but we can also apply it to chemical reactions themselves. If the amount of energy absorbed by a chemical reaction is greater than the amount of energy released, you will have an endothermic reaction, because overall the reaction is taking in energy. If the amount of energy released as the bonds form is greater than the energy absorbed to break the bonds, you'll have an exothermic reaction, like a combustion reaction, a reaction that will overall release energy. And we can write this as part of a chemical reaction as well. In these two examples, the first one, we see the decomposition of water. And this process is an endothermic reaction, because energy is one of the reactants. More energy is going to have to be absorbed in this reaction than released. So overall, it takes energy in. whereas the opposite reaction, the synthesis of water, is an exothermic reaction because energy acts as a product. It gets produced by the chemical reaction. The energy was already there, trapped in the hydrogen and the oxygen. It's just getting released as those two chemicals react with each other.